3A. What number replaces the smiley face to make the sentence true? And right now we are given 1 plus 3 plus 4 plus 6 plus 6 plus 8 plus 9 plus 11 equals 4 times a smiley face. So what is the smiley face? Well, before we calculate, we could always just figure out the whole sum and then just divide that by 4 and then we'll find the smiley face. But maybe there's a better way. I'm not sure, but let's look. So in the middle we have plus 6 plus 6. Okay, and over here is 2 less 2 away than 6, 2 away than 6. Wait, so, okay. Remember the trick of combining the largest number with the smallest number? Maybe I'm going to try that. Maybe like there's a pattern that way. Wait, so 11 plus 1 equals 12. 3 plus 9 equals 12. Wait, 4 plus 8 equals 12. 6 plus 6 equals 12. Then that must be the pattern. So let's see. So there's 12 and there's 4 pairs of them. So times 4. Alright, so now I'm going to go and figure out what 12 times 4 are. But now wait a minute. Okay, so we know that 12 times 4, that's the sum of this, equals 4 times smiley face. That's on the right side. Something's a little bit suspicious over here. So we have 4 on both sides, and it's both multiplication. So do we still have to continue calculating 12 times 4? Well, remember the commutative property of multiplication. It shows that A times B equals B times A. So 12 times 4 still equals 4 times 12. So that means that the smiley face equals 12. Notice we didn't have to add each of these 8 numbers. We just had to have a smart way, and then we didn't even have to add to the end. We just found 12 times 4 equals 4 times the smiley face, so therefore the smiley face must equal 12 according to the commutative